All right, so we have class today because we have to look at 3 theorems. Get my notes ready for that. We have 3 theorems we're going to review, and then next week got some more theorems. So I said, boy, we need to go over this together so everybody understands. Put on my badge, so everyone understands these theorems, because this is getting some good stuff here. We don't want to miss that and have anyone be confused over that. So, all right, let me see if I can get this up on our screen. Algebra 3, first hour. Keep track of where we're at here. All right, we're looking at the theorems of algebra, lesson 3.03. Let's go up to our grade screen just to check. That's the only lesson we have. Just one week, since we had a weird week with all the A days that we're missing. No A day on Monday, no A day on Wednesday because of all the other activities going on with testing and work keys and all that stuff. We just have one lesson this week, which is kind of good because there's a lot in this 3.04 also. So I feel good kind of breaking those up to where we cover one of them this week and one of them next week. So we're going to look at the theorems of algebra here. Let's switch over to our activity screen. And we'll go through this. Okay. There it is. Right. So most people, even if they're not mathematically minded, have heard of the Pythagorean theorem. Right? So the Pythagorean theorem says that the sum of the squares of 2 sides of a right triangle is equal to the square of the hypotenuse. Or as you probably recognize it, a squared plus b squared equals c squared. So most people have heard of that. They're like, okay, yep, I know. I don't know how to do it. I don't know what it is, but I've heard of that. Well, we're math people. We know this. But what is a theorem anyway? See, a theorem is a statement which does not have to be mathematical necessarily, which is proven by experimentation. In science, there's tons of theorems, and then they do lots of experiments to try to prove or disprove that theorem. We do the same thing in mathematics. We try to prove or disprove theorems. It's time to discover 3 very important theorems that will help you work with polynomial equations. All right, so after completing this, here's our essential questions. What key features of a polynomial can be found using the fundamental theorem of algebra and the factor theorem? There's 2 of our theorems. And then the third one is the remainder theorem. How does the remainder theorem allow for zeros of a polynomial to be identified? So there's the 3 theorems we're looking at: the fundamental theorem of algebra, the factor theorem, and the remainder theorem. So let's start with the fundamental theorem of algebra. Don't complicate this. This is a very simple theorem. So let's read their solution, then we'll summarize it. The solutions to quadratic equations, right, when we have a quadratic equation, x squared something, can be found by either applying the quadratic formula or completing the square or by factoring or graphing, right? And that will give us the solutions or the zeros to that equation. If the value of the discriminant, remember when you do the quadratic formula, you've got that part that has the square root of b squared minus 4ac. That's called the discriminant. If you plug it into the quadratic formula and the discriminant is a perfect square, like 4 or 9 or 16 or 25, any of them numbers that we can take the square root of and get an integer. If it's a perfect square, then that means you could factor that quadratic equation just by checking that part of it right there. So for example, x squared plus 11x plus 11, where a is 1, b is 11, c is 18. If you figure out the b squared minus 4ac, it turns out to be 49. Well, 49 is a perfect square. That's 7 and negative 7, right? 7 times 7 or negative 7 times negative 7. That's a perfect square. So that means you could factor this, and you would find out that the 2 factors, and here's the graph of it. It doesn't really get any bigger. The 2 solutions are negative 9 and negative 2. So it would factor to x plus 9 and x plus 2. But that would give us the solutions, negative 9 and negative 2. So, and this graph passes the vertical line test. We can see if we have a vertical line anywhere along there, it's only going to touch the graph once. So every x coordinate has at most only one corresponding y coordinate. So this is a function. So this can be written using function notation since it's a function. So instead of equals y, we could say it equals f of x. But the fundamental theorem of algebra tells us that since this is an x squared, with squared being the largest exponent, that means that this has two solutions or two zeros because that's the largest exponent. If this was x to the fifth plus 4x squared plus 3, x to the fifth would tell us there's 5 solutions. So pay attention to where the function crosses the x-axis. The x-intercepts are the real number solutions when it's set to 0. That's why the solutions are called the zeros of the function, because if you graph it, that's going to be where it crosses the x-axis. It's where the y equals 0. So solutions are called zeros of the functions. So there are 2 zeros to this function, and the degree of the function is 2 because it's x squared. Could there be a relationship? Yes. Let's look at the factorization of this. X to the third power minus 12x squared plus 35x. If we factor that, we'll find out that the answer is x. Oh, that doesn't get any bigger either. The factors are x minus 5, and x minus 7. Because when we graph it, the zeros or the solutions are 0, 5, and 7. So the fundamental theorem of algebra tells us that the number of zeros is equal to the degree of the polynomial. X to the third has 3 zeros. Now here's the tricky part. Either real or complex. What's complex? That's the ones that have an imaginary part, right? 2 plus 3i is a complex number. So it could be when you graph, you would only see one place where it crosses the x-axis, even though that it's an x to the third equation. Well, that would mean the other 2 solutions are imaginary solutions, but there are 3. There's still 3 solutions. 3 zeros. It's just some of them may be imaginary solutions. So if it's x to the third, it's going to have 3 solutions. If it's x to the fourth, it's going to have 4 solutions. If it's just an x, it only has 1 solution. That's what the fundamental theorem of algebra tells us. Take the degree of the largest variable, the largest exponent. That is how many solutions there are. So let's look at an example here, and we're going to do this on paper. F of x equals x squared minus 3x minus 28. Okay, having this on paper, we know, first off, that there are going to be 2 solutions because the largest exponent is a 2. 2 solutions or 2 zeros. Same thing, 2 zeros. According to the fundamental theorem of algebra. Fundamental theorem of algebra. Again, don't make this more complicated. It's very simple. Fundamental theorem of algebra says since the largest exponent's a 2, there's 2 solutions. That's it. That's very simple. That's a 2, so there's 2 solutions according to the fundamental theorem of algebra. Now we can find what those are. If we set this equal to 0, 0 equals x squared minus 3x minus 28. 28, if we can factor this, we'll get a number that multiplies together to be negative 28 and adds together to be negative 3. Well, 28 is 4 times 7. And since we want a negative as the middle term, we would put the negative with the larger number. So 4 plus negative 7 is negative 3, and 4 times negative 7 is 28. So this factors real nicely to x plus 4, x minus 7 you multiply those back together, you will get that because this is the factors of that equation. So either x plus 4 equals 0, in which case the solution is x equals -4, or x minus 7 equals 0, in which case the solution is 7. So here are the two solutions, x equals -4 and 7. That's the two solutions. And we found that. We knew there should be two because of the fundamental theorem of algebra. All right, let's see what else he's got for us. We can look to see what they got in their video. If you need to watch this video again, it is -4 and 7. They got the same solutions. They factored it, set it equal to 0, got the same two solutions. So if you want to watch that done later, you can do that. Okay, here's a good one. I want to write this one down real quick. F of x equals x plus 2, x plus 2, x minus 1, x minus 3. Okay, when we look at this, we're like, how many solutions is this going to have? According to the fundamental theorem of algebra, it's the largest exponent. But this is the factored form. You're like, well, the largest exponent's a 1. There's one solution. No, because this is factored. We would have to multiply this together to figure out what's the largest exponent. Well, we don't have to actually multiply it together because we see that there's an x times an x times an x times an x. So the largest, this is going to be an x to the 4th equation. Because if we multiply all the x's together, we go to x to the 4th. So there are 4 zeros. 4 solutions, according to the fundamental theorem of algebra. Just because it's in factored form, doesn't mean we can't still use the fundamental theorem of algebra. In fact, it's easier for us to find what those 4 solutions are. Because if we set this equal to 0 instead of f of x, we can set each of these equal to 0. X plus 2, 0 equals, they take the second one, x plus 2, 0 equals x minus 1, and 0 equals x minus 3. That'll give us the 4 solutions. So if we subtract 2 from both sides, x equals -2. This is exactly the same. X equals -2. Add 1 to both sides. X equals 1. Add 3. X equals 3. There's our 4 solutions. Now, what do we notice about it? When we list the solutions are -2, 1, and 3. There's the solutions. You're like, wait a minute, there's supposed to be 4. Well, there are 2 of the solutions were the same number. There's 2 solutions that are -2. And then this is 1 and 3. What's that look like when we graph it? How would we tell that by a graph? Well, that's a good thing to investigate. Let's see what Desmos will tell us on that. If we graph this equation and we know the zeros, the solutions equal to zeros, that's where it should be crossing the x-axis, right? So f of x equals, let's do this, x plus 2, x plus 2, x minus 1, x minus 3. So we can graph it as the factored form. And here's the solutions. So here's the solution at 3, solution at 1, and a solution at -2. That's the 3 solutions that we ended up with, right? -2, 1, and 3. That's where we expect to see it crossing the x-axis or touching the x-axis. But notice at -2, it bounces. That actually tells us something. If it bounces off the x-axis, that means there's more than one solution of -2. It actually tells us it's either 2, 4, 6, or 8 or something. It means it's an even number. There's an even number of solutions at -2. But when we see that bounce, we know, oh, there's at least 2 solutions that are the same right there. So the fundamental theorem of algebra helps us right there to know there's 4 zeros. But when we find it, we actually find out that two of them are the same. But there were four solutions. There were -2, 1, and 3. So the fundamental theorem of algebra still holds there. All right, let's go back and look at what it's doing next. And here's more. If you want another example, you can click there, and it'll go through another one with you. So you can see here's x minus 13 times x minus 18 times x plus 9. So you know there should be 3 solutions to that. There's the 3 solutions on the graph, -9, 13, and 8. But it goes through just another example that you can look at. All right, let's go forward and look at the next theorem, the factor theorem. All right, you did a great job with the fundamental theorem of algebra, right? Because it's quite simple. But not all polynomials will be in factored form. All right, that last one was real nice. It gave us the 4 factors. We know the 4 solutions. But let's investigate the factor theorem to find polynomials that will factor. All right, so in order to understand the factor theorem, you must first understand what a factor is, right? A factor is a number, a variable, a polynomial that will divide into another one without a remainder. So if we talk about a factor real quick, let's do that over here. So is 4 a factor of 12? Is 4 a factor of 12? Well, you can divide 4 into 12. You get 3 with a remainder of 0. That remainder of 0 tells us, yes, 4 is a factor of 12 because I can divide 4 into 12 an integer number of times, right? No remainder. How about is 5 a factor of 12? Is 5 a factor of 12? Oop, bring that down. We can divide 5 into 12. That's fine. Goes 2 times. But we have a remainder of 2. So 5 is not a factor of 12 because it does not go in there an even amount of times. It leaves us a remainder. So that's a factor. Like x plus 4 is a factor of this polynomial because if we divide x plus 4 into that, we're going to get x minus 7 with no remainder. Because when a factor divides in there, you'll have no remainder. So the factor theorem is going to come into play here to help us figure out a few things. Let's look at this right here. And we're going to take x squared plus 11x plus 18, and we're going to divide it by x plus 2. Because we want to know, is that one of the factors? If we broke that out into the 2 factors, because it's x squared, so it'll have 2 factors, is x plus 2 one of those 2 factors? So if we divide it by that, and you can do that either way. Remember, we learned how to do this. We can do this with long division. If you want to do long division, we'll do long division. Or we can do synthetic division because we have x plus 2. If we have x plus 2, we can. If we had x squared plus 2, we can't do synthetic. You can only do synthetic when you just have an x. Can't do x squared, x to the third, x to the fifth, anything like that. We cannot use synthetic. We'd have to do long division. But since we just have an x plus 2, we can do that. So remember synthetic division, we take the opposite of the plus 2. So we divide by -2, and we bring the coefficients. 1, the x term is 11, and then the 18. Bring the first one down. -2 times 1 is -2. Add these, that's 9. -2 times 9 is -18. Add those. Remainder of 0. Yes, this is a factor. In fact, the answer tells us, since that's x squared, this is x plus 9. That's the other factor. When we divide x plus 2 into x squared plus 11x plus 18, we end up with x plus 9 with a remainder of 0. So this is a factor. So the 2 factors are x plus 2 and x plus 9. Multiply those together, you'll get this. So the remainder theorem says since the remainder is 0, then yes, this is a factor. This means this. That's what the remainder theorem tells us. Don't complicate that one as well. It just says if the remainder is 0, then that is a factor of what you divided it into. Remainder theorem. Remainder theorem. And it works same here. The remainder is 0, so this is a factor of 12. It doesn't have to be a polynomial. The remainder theorem works with just numbers. This is not a factor of 12 because there's a remainder of 2. So that's what the remainder theorem says. Since this has a remainder 0, that is a factor. And we'll see what they do right here. Should work through the same things. Go to the end. Remainder 0. So since the remainder is 0, that is a factor. So you can watch that video if you want to watch them work through that like I did, or got confused about how I did that. All right. What about the binomial x plus 1? Is that a factor of x squared plus 11x plus 18? Well, one thing we know, since we just figured out what the factors were, we know it's not. But if we just didn't know, if we tested that first before we did this other one, we could do the synthetic division again because it's an x plus 1. Divide that in there, and what you'll get is you'll get a remainder of 8. So it is not a factor of the function because there is a remainder that is not 0. So the factor theorem states that a first-degree binomial is a factor of a function if and only if the remainder is 0. What's this mean first degree? That means it's not an x squared, it's not an x to the third, it's just an x, right? X. All right, so then it has another one. Is x plus 12 a factor of x squared plus 6x minus 72? So we can use synthetic division, and here it goes through the steps. All right, if we're going to divide that by that, set up the synthetic division. You take the opposite of the plus 12, so it's a negative 12. You take the coefficients of each term. X squared is a coefficient of 1, x has a coefficient of 6, and then you have the negative 72 constant at the end. The 1 comes down, you multiply it by the negative 12. That negative 12, now you add those together. So 6 plus negative 12 is negative 6. You multiply those together. Negative 12 times negative 6 is 72. Now you're going to add those together, and you get a remainder of 0. So that tells us, yes, this is a factor of this. Factor theorem. Here's another example. If you need another example, you click on this link at the bottom, and it works through another one. Is x minus 2 a factor of f of x equals negative 3x to the third plus 11x squared minus 8. Now, this is a good one to look at because we're missing a term. Where's the x term? When you do synthetic division, remember, we have to include every term. So the coefficients are negative 3, 11, 0, and negative 8. If you leave out that 0, your answer is going to be wrong. But when you divide by that, you end up with a remainder of 12, and so it is not a factor. X minus 2 is not a factor of that. And here's another one that it wants us to work, and it's set up a synthetic division problem. And what it wants us to do is, what's the first thing? We're going to divide by 7. And then what are the coefficients? Well, the x to the third term has a coefficient of 1. The x squared term, oh, I don't see an x squared term, so it has a coefficient of 0. The x term has a coefficient of negative 49, and the last one has a 6. So I don't like the way to do that. They should have made those boxes smaller where they line up like synthetic division, but it'll check it and say, yep, that's right. And then it wants you to continue on from there. So we won't play with that. You can work that out if you like. On paper, it'd probably be easier than their boxes. But let's look at our next theorem there. We have the factor theorem and the fundamental theorem of algebra that we've looked at. Now we have the remainder theorem. Okay, this is kind of interesting. So 2 theorems down, 1 to go. When a function is in factored form, the zeros of the function, right, also known as the solutions, the f of x equals 0, can be found by setting each factor equal to 0 and solving, right, which we did that before. We did the x plus 2, x plus 9, set them equal to 0, and they equal -2 and -9. And we knew it would have 2 solutions because it's an x squared. So the factors are x plus 2 and x plus 9. The zeros are -2 and -9. We put it in synthetic division. It has a remainder of 0. So that's the remainder theorem. I'm sorry, that's the factor theorem saying if it has a remainder of 0, those are factors. Now, it gets a little interesting from there. Let me do a different one. Let's do this one on paper because I want to be able to talk through this. So if we take x squared plus 11x plus 18 divided by x plus 1. Okay, this is the example they were trying to play with earlier. Is x plus 1 a factor of this? Well, let's do the synthetic division. That's a 1. That's an 11. That's an 18. This is the same one we did up here, except we're not dividing by x plus 2. We're dividing by x plus 1. All right. So when we do that, this comes down 1. -1 times 1 is -1. Add those together. That's 10. -1 times 10 is -10. And it has a remainder of 8. So this is not a factor, right? Because the remainder theorem says there's a remainder. It's not a factor. But let's see what the factor theorem says. The factor theorem says if we take this x plus 1 and we set that equal to 0, right? X plus 1 equals 0. So x equals -1. Let's take that -1 and substitute it into the equation. Instead of dividing it, instead of going through the synthetic division, I'm just going to take that -1 and I'm going to substitute it in. So f of -1 equals -1 squared, because I'm just taking the x out and substituting -1, plus 11 times -1 plus 18. Okay, so 1 squared. -1 times -1. -1 squared is 1, right? 11 times -1 is -11. And then we have the plus 18 at the end. Okay, 1 minus 11 is -10. -10 plus 18. Wait a minute. If I substitute that -1 in there, x plus 1 to x -1, it equals 8. F of -1 equals 8. When I divide by -1, my remainder is 8. So the factor theorem says that if I substitute it into there, it's going to give me the remainder. So that gives me another way to find out if it's the factor. So up here, we knew that x plus 2 is a factor. So let's see, if we substituted -2 into the equation, instead of dividing by -2, if we just substitute that into the equation, -2 squared plus 11 times -2 plus 18. -2 squared is -2 times -2 is 4. 11 times -2 is -22 plus 18. 4 minus 22 is -18 plus 18. The factor theorem tells me this is a factor because when I substitute it in, it equals 0. F of -2 equals 0 So that means x plus 2 is a factor. Factor theorem. Well, isn't that handy? So if you don't like to do the synthetic division or the long division, because we could have divided this by long division, you can instead take the x plus 2, set it equal to 0, you find out x equals -2, substitute that in the equation, and see if it equals 0. If it equals 0, that's a factor. Pretty cool. Pretty cool. So when the opposite of the constant term of the binomial, and what's it mean by opposite? It means since this is x plus 1, since it's plus 1, you would take the opposite, -1, right? When the opposite of the constant term of the binomial is substituted for x, the result is equal to the remainder when you divide by the binomial. The result is equal to the remainder. That first time when we divided this one, when we substituted this one in, that equals the remainder. So it'll tell us what the remainder is by just substituting the opposite number in. Substituting -1 instead of +1. So the result is equal to the remainder when the function is divided by the binomial. This is the remainder theorem. Substitute it in, it will give you the remainder. And then the factor theorem tells us whether or not that is a factor. Is the remainder 0 or is the remainder not 0? The theorem's helpful because it will help you determine whether or not a number is a 0 or a solution of the function. When the remainder is 0, the number is a 0 of the function as defined by the factor theorem. All right. So here's an important note. So the remainder theorem gives us some important facts. Given a polynomial, f of x equals whatever, x to the 4th, x squared, whatever it is. If a number a, and the number a, if x minus a is a factor, then a is a 0. So we can either use long division, use synthetic division, or factor it. And if it's a 0, then the graph will cross the x-axis at a0. You can substitute a into there and it'll equal 0. And you can substitute a into f of x and it will end up with f of a equals 0. So this is the fancy math terminology for everything we just said right here. We know there should be two solutions of an x squared. We know if this is a factor x plus 2, we can take the -2 and we can either do synthetic division and it will have a remainder of 0, or we can substitute it into the equation and it will have a 0. This one we took the x plus 1, which is not a factor, so it did not have a remainder of 0. So if it did have a remainder of 0, we know it's a factor. So that's all the fancy math ways of basically saying the same thing. Then they have some examples that you can look at. So find the remainder when 5x squared plus 51x plus 16 is divided by x plus 10. So you can do the synthetic division, and that's the two ways we can do that real quick. We can divide it into it. Here's a remainder of 6, which tells us that's not a factor. Or we could have just substituted -10 into the equation. Everywhere there's an x, -10 into the equation. And it would also tell us the remainder is 6. That's not a 0. So either with synthetic division or long division, or by substitution, we'll get the same answer. We'll find out that it's not a 0 because there's a remainder of 6, or it equals 6 when you substitute. All right, here's another example for the remainder theorem you can click and look at here. If you still need some practice with that, you could try this on paper first. Take this x to the 4th and figure out, is x plus 8 a factor? And you got two different ways to do that, either dividing or substitution. So you're either going to, if you use synthetic division, you're going to divide by -8. And if you substitute, you're going to substitute -8 and find out, does that Spoiler alert, you get -9 either way. But you should work through that on paper and see if that's what you get. Here's our lesson summary, which means that's all the 3 factors we're learning, no more to the lesson. But here's a nice lesson summary that you can use for your notes for tests. You can print this out and put in your notes. You can copy this down, however you like to have this in your notes. But here's where it talks about them. There's our key questions. Understanding what a theorem is. It's a proven statement based on experimentation. Before it's a theorem, it's a theory, right? If it's just a theory, it hadn't been proven. After it's proven, it's a theorem. So the fundamental theorem of algebra, that's where it talks about if it's x squared, it's going to have 2 solutions or 2 zeros, and that's going to be the 2 places across the x-axis, unless one of them is imaginary or 2 of them is imaginary. Then it talks about the factor theorem, says if you get a remainder of 0 when you divide, this is a factor. And the remainder theorem says you can just substitute, you use division or substitute, and either way, it'll give you the remainder when you substitute it instead of having to divide it. That's the remainder theorem. What it all means, and there's that summary again that we already went through, the mathy way of saying the same thing. So it gives you 2 pages of practice problems. So if you're like, I'm not sure I understand this, well, then here you go. Page 4 has find the zeros of the function. So here's some practice finding zeros. Here's 3 functions. It's -2. Which one of those is that a function of? Well, these 2 are easy because they're in factored form. So that's x equals 0, x equals -2, and x equals 9. So -2 is one of the factors of that one. But it'll give you more and more of them here. And you just fill them in the right place. If you put it in the wrong place, it won't let you do it. See, I tried to drop it there. It won't do it because it is not a factor of that one. But you'll work these on paper. Get the functions. Get the zeros of the functions. All right. And then down here, is this a factor of this? Try that on paper. Figure out your answer. Is it yes or no? Then you can check because you click there and it'll show you how it got it. And it may have done it differently. You might have done it by substitution. It might have done it by synthetic division or vice versa. As long as you get the right answer. And here's another one. Is x plus 1 a factor of this? And here's another one. Is x minus 5 a factor of this? If you do synthetic division on this, remember you're missing a term. There's x a third, x squared. Oh, there's no x term. You have to put that 0 in. See, they put the 0 in. They did synthetic division. All right, and then here's you try 3. Find the remainder when this is divided by x minus 2. Now, you can use the factor theorem and not have to divide that. You can substitute 2 in. When you substitute 2 in there, you'll still get the same remainder. 3 problems for you to try there. All right, and then you have a second page. So there's plenty of practice just on that page 4. Lots of practice there. But if you still need more practice, here's some here. 8 questions here. And this one's just simple. In fact, I'm going to let you put this one in the chat because this doesn't even require any work. You just look at it. According to the fundamental theorem of algebra, how many zeros does this function have? I'm going to let you put that in the chat. How many zeros? What's our answer? 0, 2, 5, or 7? Oh, see, y'all fell asleep on me. I'm going to start asking more questions throughout the lesson. Michaela says 5. She's not totally confident, but she's saying 5. According to the fundamental theorem of algebra, how many zeros how many solutions, how many zeros does this function have? Anyone want to agree or disagree with Michaela's answer? Carmine's saying it has 2 zeros. He's not confident either. Both of these have question marks. Well, let's go back to what the fundamental theorem of algebra says, just to make sure we know what our answer is going to be. The fundamental theorem of algebra says that the exponent, the largest exponent, tells you how many solutions there are. The largest exponent here is a 2. So there are 2. What's the largest exponent here? According to fundamental theorem of algebra, this is 2x to the fifth minus 3x fourth minus 5x to the third plus 9x squared minus 10x plus 7. So the largest exponent is a 5, and Michaela's absolutely correct. Since it is a 5, when we submit, it will say, great job. Determine the zeros. Now it's got one where we're finding the zeros. That one's 0 and -10. Okay. I don't know what all the kind of problems it has here. Determine the zeros. All right. So, and then it's got activity 2. Determine if this binomial is a factor. You can do that either by division or by substituting in a positive 6 into that equation. 6 squared minus 3 times 6 minus 18. I'll say it is. The remainder 0. So, and there's more problems there. If I make that smaller again, it may show us. Oh, how many we got there? Oh, 2 of 3. All right, so there's 3. All right, there it is, guys. There's a couple of pages of practice problems. So you can do those on paper and check your answer to know. And if you can kill all those right there, you're like, I got it. I killed it. That was great. I got every one of them right. Then you're ready for the assignment. There are 5 problems. And it kind of varies. According to the fundamental theorem of algebra, how many zeros does this function have? Which of the following is a 0? So in that, figure out what the 3 zeros are and which one of those is right. Is this a factor of this? And notice there's 2 yeses and 2 no's. So when you find it whether the remainder is 0 or not, does that mean it is or is not a factor? So make sure you're choosing the right one. There's 2 yeses, 2 no's. And then 2 of them where find the remainder. And it gives you 2 functions and divisors. So, all right, guys, that's what we have. 3 theorems this week. We're going to learn some more next week, some more shortcuts. So if you're trying to figure out if something's a factor or something else, you can divide it in there by synthetic division or by substituting. Right? So you have choices on that. Next week, we're going to figure out a shortcut, because right now, if I just gave you an equation like 3x to the 5th minus 4x to the 4th minus 2x squared minus 1. And I say, tell me the factors of that. That would take a lot of work. You're like, oh my gosh, I don't even want to start. And you could start dividing things into it to see if the remainders are 0. And you could start substituting in there, see if the remainder is 0. And you could spend an hour doing that. Next week, we're going to learn a shortcut to where you don't have to check every number you can think of. There's only certain numbers it could possibly be. And we'll learn that next week with more theorems. So, all right, go through this. This is due Sunday. Then next week, we'll get into more good stuff, more theorems. But that's all I got for you today. Have a great weekend. Glad you came. Good job, everybody. We'll got questions, let me know.